So let's start our new course. In this course, we'll discuss details about the engineering geology and geomorphology. So the first question may arise. So why we should let's first introduce with the background of this course and the necessity of this course in our civil engineering. Why we should learn this, as you know, geology, geomorphology. So these
স্যার
are okay.
স্যার স্ক্রিন দেখা যাচ্ছে না স্যার
দেখা যাচ্ছে না? Wait. Offline. Why should we learn this the geology, as the geology is a different subject, different branch of study. Geomorphology, these are the distinct subjects for broad study. So
স্যার স্ক্রিন দেখা যায় না
এখনো না?
স্ক্রিন শেয়ারিং হচ্ছে স্যার।
ঠিক আছে না?
না স্যার দেখা যাচ্ছে না, শুধু লেখা উঠতেছে স্ক্রিন শেয়ারিং, এটা লেখা উঠতেছে,
দেখা যায় না।
স্ক্রিন দেখা যাচ্ছে না?
না স্যার।
আচ্ছা ঠিক আছে, শেয়ারিং অফ করি। দেখো তো।
জি স্যার।
ঠিক আছে। আজকে একটু নেটওয়ার্কে প্রবলেম করতেছে ক্যাম্পাসে, যার কারণে আসলে একটু প্রবলেম হচ্ছে। So let's start again. So the question may arise, why should we know this course, as there is another subjects like geology, geomorphology. Those are the large scale of studies. So actually in this course we will learn the geological features or the other things related with only civil engineering or commonly in engineering. So in our civil engineering branch, there you may know in future study there may basic 5 distinct branch: the structural engineering, water resource, transport, geotech, environment, etc. And now sometimes sustainable developments or something else. So in each cases for the further study, all the cases, the things related with the earth in any form. Okay, so for those point of view, we need the geological knowledge, the basic geological knowledge regarding to our engineering practice and problems to identify. And next, so at the very first of this lecture, let's us discuss with the geology and geomorphology, two term. The first one is geology. So the geology is the subject which deals with the study of physical properties of the planet Earth. That means the planet. Okay, the all the things, its inner, outer, each and every things, and its interaction with one another. All these are known as the geology. And geomorphology, this is actually the physical features of the earth crust. That means the upper portion of the earth crust. Later I will show the different section of the earth. So this portion and its geological features, its interaction, these are the included in the study of geomorphology. So it's only discuss the outer surface or most outer crust of the earth. So in reality, geology, this is actually a huge branch of study, and geomorphology, this is actually a subset of geology. Okay, that means geology is a global thing, and geomorphology, this actually deals with only one part. And this is some geomorphological features. Okay, so some example. Actually, if we look for our Earth surface, this there is a wide range of variety throughout the globe, and in this case these variations and why this variation occurs and how this change throughout the time. So these all these things are the study of geology. And then let's show why with a civil engineer. So our task is really related to building. Our task is related to the bridge construction, dam construction, river training, environmental effect, and many other things, environmental sustainability. So these are the irrigation, flood control. These are the branch of our study, civil engineering branch, and our scope of practice. So why should we know the geology? Okay, in all the civil engineering works, those are the carried out on the ground. Most of the case, maximum structure or any civil engineering works that starts from earth surface. That means the ground. Okay, ground level. From ground level, we starts our works. So the properties and the of this earth and subsoil in our engineering practice, civil engineering practice, we always mention it as a subsoil. That means below the ground surface. So for the below ground surface layers, that means as you many of you may know, the earth is formed not in a single day. It's earth crust is formed through many geological process and thermal, mechanical, many changes, etc. So while going through this process, there are different layers in the earth crusts created, and this may also visualize in the open eyes, like you may see in Chittagong, the color of the earth's outermost earth surface is different from any other areas. The texture, the quality, each and everything varies from one location to another location. That means there is a wide range of variety throughout the surface and also throughout the depth. Okay, so not only in the surface, also this change occurs in the depth. So we should know the details about the subsoil while we go for any civil engineering works. The first step is to starts from the foundation or the subsoil investigation. In civil engineering practice, basically in geotechnical engineering branch deals with these details, and in geological engineers or the geotechnical engineers termed it as the site investigation, a very common terms when you will go for further study or you will go in the practice level after your graduation. While you will go for the practice, the this is a very common common term for a civil engineer, that is the site investigation. Site investigation means if I choose a site for the any specific project. Suppose for any project you choose a site or location, so in this location you need to know all these geological features. Basically not all those are related to our engineering practice or in our design parameters. So only some specific points we try to figure out. This investigation is called the site investigation, or sometimes called subsoil exploration. That means we explore the subsoil and underneath our ground. So what's are the layers? Say suppose there may be different types of layer, 4 layers, 5 layers, and we will go for a certain depth required. Okay, and these are the actually these operations are done by drilling. Sometimes you may also see in our Chuet or any other location, there's during construction the borehole is created at different points. After putting the boreholes, the soil samples, subsoil samples are collected and then examined by visual inspection or sometimes by laboratory tests to find out the layers. So okay, to find out how many layers exists or how many layers with which depth or the thickness of the layer, and these all. So these are the necessity, and finally for a civil engineering design we need the geological knowledge. So next, this is actually a scenario. This is uh, in the Bhattiari. Okay, in actually hilly districts, these types of geological features is common. Some with the ground undulation, with some high water level. Okay, so while you will go for a site investigation, the it's become sometimes challenging, or it's a scope of thing to who find which types of geological features or which types of soil condition may come in this location. This is very unpredictable. In our civil engineering practice, we always say that the soil or the geological feature was the soil portion. This is the most unstable portion. Okay, this is the most unstable because this is always underground. Okay, we without any examination we can't see this. So for a superstructure you can see the alignment, or you can see during the construction, if the construction is okay, then the quality is okay. Okay, but for the subsoil you may know and even not sure what's beneath underneath the layer. Suppose you go for up to 20 feet or 30 feet, so you don't you have only the data of these portions. Okay, and you may not know what beyond this level. Okay, so and for other cases, like if you go for the environmental sustainability, you have the air quality data of a city. Okay, or for a whole city you have the air quality data, or for the whole city you have the noise data, or may you have the pollution data, everything. For a river, in most of the case you have the uh, data available, or you have knowledge, but it is impossible without exploration or without investigation. You may not never make a conclusion for a specific point. This is actually this portion, this is actually a picture. These pictures are collected from a laboratory and few years back, I think in 2017 or 18. One client, those are actually Bangladesh BMA. Okay, BMA in the Bhattiari range, they found such types of soil. These soils are very hard, so they are going for a firing range in the deep portion of the hill. For so while they are excavating to make a plain land, and they found these very hard rock type materials, so soil, hard type soil. So these are very common in the hilly region, but sometimes uncommon, because they bring it to us. So what is this? These are the very hard to excavate. That means general excavator can't go through further excavation. So they face a problem, and when they come with this, we saw that these are the actually the shale types. These are the types of soil. These soils are actually in reality, if you see this is a very hard solid materials. And later I will show. Let's next one. So in very hard condition, we if we reshape it in the cylindrical or cubic shape, and we find the compressive strength test. So this is the very high strength. Look like in general is you may conclude, make comments like, okay, this is a rock type soil layer, or this is a very hard soil layer. Okay, this question may anyone may conclude this, but actually and they also predict this, because this is a hard layer. Okay, but actually this is a shell types of shell type soil. That means shell layer. It's in different types of layer sometimes arise. These layers are actually clay, very soft. Clay are in generally soft. When it go for some geological feature, geological activities like pressure, overburden pressure, or excessive um, pressure, it solidifies, and as it is clay, when it solidifies so under pressure, the water explodes and the dense it becomes dense. So due to the density, and these things was happened in the dry season, so the water level is also lower, and also additionally this is in hilly area, so the condition is dry. So in dry condition, it acts like a solid or hard materials, hard soil. But when in the rainy season, or when water level will become higher, it will act like a clay. So this is very difficult without just seeing, or without any details investigation, to make a comments, or to make a complete decision in the geological activities, or in geological layers. So this is very unpredictable. I am showing just one example. So how our interpretation is affected, or how our interpretation and can be misinterpreted through these types of specific problem. So and there is another example. This is regarding the ground conditions. So as I say, the geological layers are changed throughout the surface level, also in the depth. So for this case, here this is another plan. This plan is actually for a LPG power plant. LPG plant. Okay. For this plant, actually, discrete order, maintaining some rules. So um, while we are going for these specific cases, we found that he says, suppose here this is one uh, plant, and another plants, there is a three plants. So the distance between these plants and these locations, borehole locations, are only 20 feet maximum, maybe maximum 20 feet. But while we go for the subsoil exploration and soil investigation, after investigating, it was found that there is a difference in soil layer. That means these 2 points are within 20 feet. Okay, suppose person is standing in ground at 220 feet apart, but they don't know the soil layers or the geological features are entirely different from each point to other points. So it is very difficult to predict. So this is another example, and the variability of the geological features. And this subsoil in investigation, or the subsoil exploration, these will be details discussed in details in the in our course Geotechnical Engineering 1, Geotechnical Engineering 2, and in fourth year the specialized course in Geotechnical Engineering 3 and 4. So these are the actual study of those subjects. We are just showing the importance, and how will these operations or these activities are occurred. So we will learn it in the later higher courses. So this is the actually the engineering geology. So from engineering geology, we need to know the load carrying capacity of soil. So if we want to build any structure, we need to know the entire load of structure will be transferred ultimately in the soil. So we need to know the load carrying capacity or bearing capacity of that soil. If the soil is soft, its capacity will be less. If the soil is a hard layer, so this is safe to rest the load of the structure. So and another importance, this is the based on the our structural design, and another is the from the geotechnical hazards. This is the most important point for engineering, because geotechnical hazards, these are the actually sometimes most of the cases it's natural, or some cases it's man-made. So the geotechnical hazards actually include the landslide hazard, earthquake hazard, soil liquefaction. Okay, so these are also details part of study of geotechnical engineering courses, but we will this course also includes some basic portion of the earthquake hazard and landslide also. So these are actually some we will give some basic hints. In earthquake, this is totally a natural and the mechanism of earthquake, why earthquake occurs, and how it propagate, and how to predict or mitigate these types of earthquake hazards. So these are the also study of geotechnical hazard, and again the landslide hazard. Why landslide occurs, debris flow occurs due to the landslide. You may sometimes see in news the many people dies, many structure damaged due to the landslide or earthquake. So these hazards are actually the geotechnical hazards. So if we want to mitigate, or if we want to work with this geotechnical hazard specifically, we also this geotechnical hazard mitigation or prediction, or its preventive measures, anything, these are the part of our civil engineering studies. So if we want to go for this branch, we also need the engineering geology, the clear knowledge of geology. Again, the geology of the regional geology, that means this is again the geology varies from one region to another region. So suppose you study for one area for Bangladesh or any country, later you will go for job in another country. So if you works with the geological features, in that case you will distinctly know to details geology of that specific location. Even in throughout our country, we are growing in Chittagong or study area or anything. So we always consider with the Chittagong, we are showing example of Chittagong landslide hazards, earthquake hazards, or any other things, the subsoil characteristics, etc. So if you go for another points or another locations, the geological features it must be totally different from another point. So you need to know details about that region. So this is the ongoing process. Again, this is one application of geology. Okay, so we already discussed some points where we can apply our geological knowledge, or the geology in civil engineering. First one is the if you go for the safe foundation, if you searching for the foundation laying, this is one point. And another point, this is the alignment. Okay, another point, this is the alignment of any road or tunnel or bridge, anything. So sometimes we conduct from our department some works like the geotechnical investigation for some specific projects, and if for a bridge we conduct the morphological study, that means morphological study, and morphological investigation, hydrological investigations, and including this along with the geological features or the subsoil investigation. Combining all these things, we actually decide where we should go for a alignment, where we should create the alignment of the tunnel or bridge or road. And another things I will show in next slide, what will be the problem if we don't consider these things. So these figures actually shows it's and the Cornfully tunnel projects are Cornfully Martillion tunnel project is ongoing. Actually these slides are prepared a few years back. So searching for the question may arise, okay, the Cornfully, this is a river, so if where the distance is short, I should go for the alignment of the tunnel through this the shortest distance. Okay, so this will reduce your cost. Okay, and this will also reduce your manpower cost, travel distance, etc. But sometimes the shortest distance is not the good choice, or is must. Okay, this is mandatory. Again, for the current of river, for the deposition and silting and scouring and another hydrological parameters of rivers, this is also another importance for laying any tunnel or bridge, long bridges, because not only the structural portion is important, as well as the hydrological portion, morphology, these are also equally important. So these study areas are interrelated to one another, and while you go for Cornfully River, this is a great problem. Suppose if you visit the east portion, CUFL or Anwara, this portion, that is the east portion of the Cornfully River, this portion is actually undergrowing. If the Cornfully tunnel is once completed, this area is underdeveloped area. Rapid urbanization will occur. So in these areas, the associated uh, portion, associated river bank, this huge amount of uh, siltation is occurs, the sedimentations. So this is a tidal river, so the sedimentation is a major problems in this regard. Actually, if suppose if you plan for a colony or a industrial area, focusing the river flow path, because the riverway transportation, this is very easy. So if you consider, so okay, I am planning to propose a project regarding this, using this river path, but a few years later, suppose 10 years or 20 years later, you may find, okay, the flow path of the river is changed. Okay, the river go far away from your study area or your proposed area. So you are developing a area focusing the river, but river goes away from you. So what will be the problem? Okay, the entire plan will not be completely established. So to understand the flow path, this is the study of river basin, the catchment area, and any other things. This the hydrological study of the river. So this is equally important. Another geological features. And next one, this is a major example of major highway depressed after the Gorkha earthquake in 2015. So after 2015's massive earthquake, here some red lines are shown in this figure. This is actually highway, and some red lines are shown, like looking like contour line. Okay, you may know the contour line. So what was the actually problem? While this road network or the highway is created, the some geological points are omitted, like these red lines are actually depressed. So what is the reason, what may be the reason behind this? Basically, there may be some soft soil layer beneath this specific point, or sometimes there may have some fault line, hidden fault line of earthquake. Those without proper geological investigations, the location of fault line at the exact location, or its the intensity or its activity level, to know the activity level, sometimes the fault lines are hidden, or sometimes the fault levels are not active. So for those cases, we also need to know, okay, it's maybe no, it may not active now at this point, at this stage, but it may active after 10 years or after 15 years, 50 years. So while I am planning for this area, should keep in mind that there is an active fault line, or there may have some soft soil in the underneath areas. So if you go, you will study the details of road networks, or how to design a road network in the transportation engineering courses. But you may find for the road network, we not need to go for too much depth. Okay, for all of you are familiar with the road constructions in our national highway or any other roads. In both cases, you may find the one layer is scraped from the soil, so then it is refilled with the stone or brick chips, sands, or foreign materials, etc. And thereafter it is compacted, and the finished road is created. So basically, in the flexible pavement or our road, it's not necessary, because the load, vehicle load, is a moving load, so the load is not so high like as a structure. And sometimes only up to 5 feet or 6 feet or less, and after certain depth, the load is eliminated. So this is not a problem. But the problem is, suppose up beneath 10 feet or 8 feet, there may be a soft layer. So when earthquake waves will come, and then it will shake the entire area. And the soil liquefaction, it's another term. This is a massive damage of earthquake hazard. Yeah, so in general, it's not a problem. But for if higher intensity or of earthquake is hit in this area, so maybe some portion of the highway will be depressed, or some portion will be upheaved, like this. So in these cases, most probably there may have some organic soil or some soft soil in some specific point. That's why this the highway is depressed. So these are the some basic discussion about engineering geology, why we should know the geology, and what is the application, prospective application of geology in our civil engineering area, and how should we go. I try to give some basic idea about the geology and its interrelation with our civil engineering courses, as well as our civil engineering practice. Now let's come to our course content. Actually, the first lecture today I discussed with the introduction to engineering geology. That means I try to introduce with what is the geology. Actually, there are many other things in geology. The changes, how it changes, the rock, fault location, fault line, and many other things. They are investigation process, and this is a vast knowledge. So we all only discussed with the geological point that's related, or terms related with our civil engineering problems. So the next is the topics are the minerals. The minerals, their identification, their physical properties, rock forming minerals, etc. So the minerals, actually, this is another known terms. So most of the minerals are found from mining or any other process. So we will discuss. Actually, this course is a theoretical course. The mathematical portion is less. In some cases you will find this, but most of the cases, suppose for minerals, mineral identifications, their properties, their locations, source, their physical behavior, chemical behavior, etc., and their common rock forming minerals, etc. These you need to memorize some names of the minerals, like the minerals of iron, the minerals of magnesium, the minerals of aluminum, etc. And thereafter, the rocks and the types of rocks. These topics is already known to you, I think, in uh, general science. Maybe in general science or any other courses, you know the rocks, three types of rocks: igneous rock, sedimentary rock, metamorphic rock, etc. And then rock cycle, how the rock is recycled. I think in geography or geology. Geography maybe. I'm not sure is it still in your course content or not in the school level, high school level. At our time we got a course maybe in class 9 or 10 like this. So are the some types of rocks, their formation etc are discussed. So these are the, I think this is the known knowledge, just we will learn in some advanced level. And next, the fold, fault, and joint. So this is the a geological fold of the plate joint, etc. And weathering and erosion process. This is the geological process, how the earth upper crust of the earth is changed day by day. The geological formation is changing throughout the 100 years, million years. So this is the process of the geological changes. And next one is the type of drainage basins, quantitative and qualitative analysis of the drainage basin. This is the study of something related to with the hydrology or hydrological study. The for a river basin, suppose for a river, it collects water. Say for our river Kornofuli, this upstream is from Assam. So while it's traveling from that starting originating point to Bay of Bengal, it travels a large distance, long distance. Okay, while it's traveling a long distance, it connected with many canals. Okay, many canals or small rivers in some cases. So canals and then again another small canal. So it's something like a network, water network. Okay, so all of these canals actually collected water while it's raining or rainy season or the precipitation occurs. It collects, the small canals collects water from the its adjacent area, then it collected by the canal and it comes to cumulative form and finally it deposited to the river. Okay, so that means the area, the total area which is covered by a river, that means the catchment area, this is actually known as the drainage basin. That means one river acts like a drain for a certain area. Okay, so this there are the different shape, type, and analysis of the drainage basin, how to calculate the drainage basin. Okay, the drainage basin and this analysis, different types of analysis are also included in these topics. And next one is the geological works done by river and wind. Some geological features are changed across our upper crust by the rivers and winds. So these are included in these portions. And the next portion is the earthquake fundamentals, seismic map of Bangladesh. So this is another large topics. These topics actually discuss the basic propagation of earthquake wave, etc., along with the seismic map, the earthquake intensity, based on the earthquake intensity and other hazards. So how to mitigate the earthquake again, what is the problem, possible hazardous locations and the susceptibility of earthquake. Again, the next one is the landslide and land subsidence. Landslide means this is a common in the rainy season, and sometimes land subsidence. This also occurs in due to some mining activities. So, and next one is the geological investigation for the dam, reservoir, tunnel, highway site. So this is some of the types of geological investigations which points will be covered. So these are the discussed in these topics. Again, the geological succession of Bangladesh, folded bed in Bangladesh, faulting in Bangladesh. So this is a very small topic, and this topic will focus on the geology of Bangladesh. That means the position of folded bed, fault, the geological features of Bangladesh. And next one is the seismic investigation and the tsunami, its possible effect. Thus, actually, this tsunami is related to the earthquake. So these topics will covered concurrently. And the last one is the, this is another theoretical portion. This is the mineral deposition of Bangladesh. That means in many points of Bangladesh, many areas, some minerals are deposited. So these minerals, their activities, their properties, etc. So these will covers in the these topics, the mineral deposition in Bangladesh. So this is the overall course content. Along with this, most of these are the theoretical portions. So I will conduct the class in presentation, and I will try to give you the lectures as well. So it will be easy for all of you. Actually this course is mostly mathematical portion is very low. So I will try to put some assignment based on some problems as well as. So this is our first lecture, lecture 1. So at the next, actually I will conduct two successive lecture today. So I think we can take a break. Okay.
স্যার স্যার আমি 16 ব্যাচে, তো স্যার আমি এখন থেকে এখানেই ক্লাস করব।
আচ্ছা, সমস্যা নাই, যে ব্যাচেরই হও। তোমাদের হচ্ছে আরো কয়েকজন মনে হয় আমাকে মেইল করছে। সবাই হচ্ছে, তোমরা অনেকে আমার সাথে যোগাযোগ করতেছে, সবাইকে হয়তোবা আমি সাথে সাথে ফিডব্যাক দিতে পারতেছি না। সো তোমরা যেটা করবা, একটু ওদেরকে লিঙ্কটা দিয়ে দিবা। 12 ব্যাচের একজন যোগাযোগ করছে, ওকে আমি দিছি। 16 এর আরো একজন যোগাযোগ করছিল। এনিওয়ে, তোমরা হচ্ছে যারাই থাকে সবাইকে ইনফর্ম করে দিবা, সমস্যা নেই। তো ঠিক আছে, এখন আমরা, হ্যাঁ বলো
স্যার। আমাদের মানে রেজিস্ট্রেশনটা কেমনে হবে? আমাদের তো স্যার আসিফ স্যার আমাদের ওই স্যার অ্যাডভাইজার স্যার। স্যার তো অসুস্থ স্যার। আমি
কোন ব্যাচ?
ফলো ব্যাচ
আসিফ স্যার। আচ্ছা, স্যারের সাথে একটু কথা বলে নাও। রেজিস্ট্রেশন তো তোমরা এখনই তো করতেছে না মনে হয়, এখন তো কনসার্ন নিয়ে ক্লাস শুরু করে দিচ্ছ, বাট রেজিস্ট্রেশনটা এসে করতে হবে। হ্যাঁ, তো
কিন্তু স্যারের মানে ফোন দিলে তো পাওয়া যাচ্ছে না, স্যার তো অসুস্থ জানেনি।
স্যার এমনিতে আসে, ডিপার্টমেন্টে আসে খুব কম। স্যার এখন মোটামুটি সুস্থ, ধরো আসে যে অতটা আসে না আর কি। মাঝে মধ্যে উইকলি হয়তো একদিন আসে, 2 দিন আসে, ওইটা সমস্যা নাই। তোমরা হচ্ছে ঠিক আছে ক্লাস করো, স্যারের সাথে স্যারকে মেইল দিয়ে রাখতে পারো, এসএমএস দিয়ে রাখতে পারো যে স্যার
মেইল দিয়ে রাখছি।
একটা এসএমএস দিয়ে রাখতে পারো যে স্যার এরকম আমরা কোর্স করতে যাচ্ছি, সো আমরা ক্লাস শুরু করতেছি, আপনার স্যার পারমিশনটা লাগবে। আর এরপরে যখন তোমরা রেজিস্ট্রেশন করবে বা করবো, সেটা হচ্ছে হয়তো স্যারের সাথে আইসে ইয়ে করে নিব। স্যারের সাথে এসে তোমরা কথা বলে নিবা। আর অ্যাটেন্ডেন্সের ব্যাপারটা হচ্ছে, যারা ক্লাসে অ্যাটেন্ড করতেছো সবার তো রোল নাম্বার দিয়ে করা না, প্রথমে রোল নাম্বার দাও। হ্যাঁ, নেমটা তোমরা ওইভাবে রিনেম করবে যাতে রোল নাম্বার থাকে। সো অ্যাটেন্ডেন্সটা আমি অটোমেটিক নিয়ে নিব, অ্যাটেন্ডেন্সটা।
কিন্তু স্যার আমরা তো কোনো ক্লাসের ইনভাইটেশন পাই না কখনো। এগুলো তো স্যার যে ওদের কাছ থেকে, ক্লাসমেটদের কাছ থেকে নিতে হয় লিংক গুলো। এভাবেই
ইনভাইটেশন এটা তো কমন। তোমরা গুগল ক্লাসরুমে জয়েন করছো? গুগল ক্লাসরুমে কয়জন জয়েন করছো?
স্যার ওখানে জয়েন করছি, কিন্তু গুগল ক্লাসরুমে তো এখনো কোনো ক্লাস হয়নি।
না, গুগল ক্লাসরুমে ক্লাস হয় না। গুগল ক্লাসরুমে দেখো একটা জুম ক্লাসের শিডিউল প্লাস লিংক দেওয়া আছে। তো ওইটাতেই হচ্ছে গিয়ে ওইখানে দেওয়া আছে, দেখো পোস্ট করা আছে ক্লাসের যত অ্যানাউন্সমেন্ট, আমি সেখানেই দেই। ওখানে দিলে ওইখান থেকে তোমরা হচ্ছে ইনফরমেশন পাবা। গুগল ক্লাসরুমে অ্যাড করা থাকলে তোমরা নোটিফিকেশন পাবা, ক্লাস রিলেটেড যত নোটিফিকেশন হয় সব আমি ওইখানে দেই। ক্লাস ক্যান্সেল হইতে পারে, রিশিডিউল হইতে পারে, বা আর লিংক একটাই দেওয়া আছে, দেখবা যে জুম লিংক থ্রু আউট দ্য সেমিস্টার এটাই চলবে। ঠিক আছে, হয়তো ক্লাসের টাইমটা চেঞ্জ হইতে পারে বিভিন্ন কারণে, বাট ওখানে একটা মিটিং আইডি পাসওয়ার্ড দেখবা দেওয়া আছে, জুম মিটিং লিংক দেওয়া আছে, এইটাতেই হচ্ছে পুরোটা কভার করবে। ঠিক আছে?
আচ্ছা স্যার, ঠিক আছে।
আচ্ছা, ওকে, তাহলে এখন একটুখানি ব্রেক থাকুক। আমি মনে হয় 11:10 থেকে আবার শুরু করব। ঠিক আছে, নেক্সট ক্লাসটা। তোমরা থাকো, কানেক্টেডই থাকো। আমি 11:10 থেকে হচ্ছে আমাদের সেকেন্ড লেকচারটা কিছুক্ষণ ডিসকাস করব, করে দেন আজকের মতো ক্লোজ করব। ওকে, আর second lecture, the lecture 2, this will covers the some minerals and rocks. Actually I will discuss some rocks and minerals, and then you need to no details, or I'll just discuss some points. All of those minerals have the same types of properties, use, locations, etc., source, etc. So the reference book for this course is the only one. Geology for Engineers, Aurora. So you may collect these books, or sometimes I will provide some scanned materials as well as the class lectures. So hopefully this will be enough. For minerals and rocks, let's start with why the minerals and rocks are important for us. So again, the same thing, the engineering problems, the civil engineering problems, those are related with our foundation. Okay. So for foundation, it is always desirable to say place our foundation in a safe location. That means in a hard strata or hard soil layer. That means if the underlying layer is hard, so our foundation is safe. Okay. Recording. Okay. Sorry.
স্যার বইয়ের নাম কি স্যার বলছিলেন?
Geology for Engineers.
স্যার রাইটারটা?
Aurora. Most probably KR Aurora. I'm not sure.
DS Aurora, sir.
Sorry, DS Aurora. Just a minute. The recording is started. Okay. Let's start. So this is an this is an example, typical example. Say in our outer crust, the upper portion, that means the surface level, these have the low density, and as we go for further depth, the density, this is a common trend. Sometimes it's may be different, but in general, with the increasing the depth, the density is increased, because the underlying layer carry the load of the overlying layer. Okay, so that's why the density, and it is compressed, and the density is obviously higher comparing to the upper one. So if you go for further depth, the density is increased, and sometimes at greater depth you will find an mineral rock layer. Sometimes if the structural load is too much high, or sometimes the overlying layer is so soft with the water or clay type, in that case we go for pile foundation, or the deep foundation. These are the called the deep foundation. So for these types of civil engineering works, we need the knowledge of rocks and minerals. The rocks, these rocks are actually nothing but the aggregates of minerals. There are some minerals we will discuss, and the rocks are actually formed by some minerals. Those are the compressed forms of minerals, and then solidification, after the solidification it creates the rock. So next start the earth minerals. The minerals are actually the naturally occurring inorganic crystalline substance, is with the with some narrow range of chemical compositions. That means some minerals have 2 or 3 types of chemical compositions, depends on the its formation process, and the it have the distinct characteristics properties. So most minerals are composed of the 2 or 3 elements. Actually, while we go for the chemical composition, we will show some chemical composition, typical chemical composition. So you may find 2 or more elements, and sometimes in associate with water. So these are the mineral compositions. There are many minerals in the earth. If you searching through the earth, there are many, more than 3,000 minerals you may find. However, Some are the minor. Most major minerals are the very common, known to us. And here is some elements, name of elements, that means oxygen, silicon, aluminum, ferrous. Sometimes or some are others missing here. And those are the calcium or magnesium, sodium, like this types of elements composed to form the minerals. So here is an tabular representation of some minerals, like the some important minerals here: calcite, dolomite, graphite, gypsum, halite, and quartz. These have the chemical composition, their color, and the successive columns represents their properties. So some here among these some examples. Some minerals are known to you. So first of all, the quartz. Do you know what is quartz? This chemical composition is silicon dioxide. Okay, so this is very known to us. The quartz, this is nothing but silica. It's a very common element of sand. Okay, sand is very known to us. The sand is actually composed of silicon, silicon dioxide with others. So this is actually quartz. And another one is sodium chloride, halite. This is the naturally occurred sodium chloride, naturally occurred chloride. This is the halite. Gypsum. This is another known things. You may find the use of gypsum in our cement production. Okay. This is known to you, gypsum. It is a basic element of our cement. Okay, gypsum, calcium sulfate with two atoms of water. So this is actually natural minerals. Dolomite, calcium carbonate, calcium magnesium carbonate, calcite. This is not the calcium carbonate. So these are the known things with the chemical compositions, and their colors are also shown here. Quartz, this is a variable color, mostly colorless or white. Halite, this one is also colorless. Gypsum is colorless. Graphite, dark gray. Graphite is also known to us. This is the use of pencil lead. Graphite is mostly used. Dolomite, this is white or pinkish. This is in powder form minerals, and in many minerals shows 2 or 3 colors. Sometimes it's not defined. Depends on its geological process. Many minerals have shows 2 or 3 colors depending on the formation, and this is the hardness. So some hardness value. Later I will show what's the scale of this hardness or the unit. So it have other characteristics like the taste, texture, etc. And primary rock. That means these minerals are linked with some rocks like calcite. It creates sedimentary and metamorphic rocks. Similarly, dolomite, it creates sedimentary rock. Graphite, the metamorphic rock is compressed with the graphite, and the sedimentary rock, the gypsum and halite. And quartz, this is a common things. It may be found in any types of minerals. So here are some figure, some common rock forming minerals. Silicate in the silicate minerals, silica minerals like feldspar, quartz, muscovite, etc. These are some figures for each any types of minerals. This is very easy. You may suppose you need to know details about more details about the feldspar. Just search in Google the mineral feldspar and its properties. If you search, you may find in Wikipedia, or you may find its details in many other sources, or many other literature. So this is very common or easy. Another example, this is actually granite. This is the figure of the typical picture of granite rock. So this granite rock actually composed of many minerals. 2 or 3 or 4 minerals are compressed or combined in a single rock. So this granite actually covers the quartz mineral, feldspar, and biotite. So these three types of minerals, and sometimes in some specific rock, if you collect sand from a river, sometimes you may find some round round stone. It's very common in the river, like if you go for Jaflong or some other rivers where the rocky rivers, that means the rocks are always rolling around and the sand rocks are collected from those rivers. So in those locations you find sometimes these types of rock or a piece of stone, those have a color combination. Like I found some cases this looking like reddish white. Okay, some portion is red, some portion is white, some portion is a deep brown color, or sometimes it's a shade of the dotted shade of green to red or reddish or white. So this is a visual inspection. Okay, if you go for further in any tour or sometimes you may just look for a specific stone. This is very common in Slate belt. So if you go, you may find it's just take a piece of rock or stone. You may find, so this is composed of many minerals, and it is show different color combination. So this is an the real example. Another here is the actually the mineral identification. This is one part of our this study about minerals. First, the mineral identification. So the mineral identification is actually composed of two part. First one is the in general or conventional parameters of mineral identification. That means based on our the physical properties. That means we will examine the physical properties of a mineral, then we will decide about it. So the most common properties like the hardness, cleavage, crystal form, color, stake, etc. So these are the very common. Among these, the hardness is classified or categorized based on the hardness scale. This is the Morse hardness scale. So in Morse hardness scale, the hardness is numbered from 1 to 10. That means hardness 1 is very soft materials or less hardness value, and hardness 10, this is equivalent to diamond. That means the most strong materials or hard materials in art still now, diamond. So diamond is scaled as 10, and the compared to these others the minerals are scaled. So here is with an example like mineral talc, gypsum, fluoride, apatite, quartz, corundum, etc. So with some example. Wait. So this is the hardness scale, and next,
Sir,
okay,
cleavage, streak এই properties গুলো কি?
okay, I will discuss one after another. The next one, this is the cleavage. Cleavage means the look at this figure. The minerals sometimes have a breakdown. So the minerals need to be break down to identify its cleavage. Cleavage of the minerals is it capacity to split more radially in certain direction. That means suppose some minerals are in the plate type like mica, biotite or muscovites. That means its microstructure. This is actually my microstructural properties. This microstructure shows some plate type elements. That means some 2 or 3 or more plate types elements are compressed to create one minerals. Or in figure B, look at figure B, cleavage in 2 direction. That means 2 direction at right angle. That means these are actually if you compare this with like stick noodles, okay, some sticks, rectangular sticks are compressed in a dense to create this is the ortho class one example. So this is the 2 directional cleavage, and first one was the 1 directional cleavage, and the third one this is the cleavage in the 3 direction at right angle. These are the example of halite and galena. That means its elements are like something looking like the cube, okay.
খালা আমুরে খাইতার মনে আমি রেখে দিলে তাহলে
This is actually here is another example. Okay, let's the previous one, the 3 directional cleavage at right angle. So this is looking like Rubik's cube. Many of you are known to this. That means many cubes combined to a large cube, okay. Though all the elements are in cubic shape, right angle, 3 directional right angle texture. So these are the example of halite and galena. And another one, cleavage in 3 direction but not in right angle. This is calcite and dolomites. That means these are not in right angle. So the elements are some tapered shape. And cleavage in 4th direction. That means here in this fluoride and diamond, okay, the texture of diamond is known to you. All of you know the shape of diamond. That means it's like trapezoidal, okay, something like trapezoidal. So or pyramid shape, okay. So this is cleavage in 4th direction, and another one is cleavage in 6th direction. So these are the typical few types of cleavage. Based on this, if you know the proper suppose you find in minerals in the field or in any investigation, so you will match its property like its cleavage, its color, its luster, its hardness value with the standard one. So if you match these values or its properties, so you may easily go for a conclusion, so which types of mineral it is, okay. So these are the actually use of this property. And here is some color picture with some explanation. That means cleavage in 1 direction, 2 direction, that means 2 plane, and 3 direction, that means in 3 plane it can be divided, and with the cleavage in 2 direction or 3 direction with not 90-degree angle. So these are some illustration. The next one, the next property is the color, streak, and luster. The color of a mineral, this is actually the point for identification. There are 2 types of color shown in the minerals. First one is the inherent color, okay, to the composition of minerals and the arrangement of the constituting atoms. So this is the inherent color. And the second one is the exotic color. This color is actually depends on the presence of impurities or fracturing in the minerals. That means if the minerals contain some impurities, sometimes it will change its color. So and the pure minerals shows different colors. So this is the 2 colors, the inherent colors and the color exotic color. And the next one is the streak. Streak is nothing but another characteristics of color. That means this is also color but in the powder form. That means if you powder a mineral, okay, if you take a minerals and powder it, so you take it powder form, in that case its color will be changed, okay. This powder is radially obtained by crushing the minerals in the fine powder or by making some hard or slightly rough surface. So this is the streak. So there is a difference in color and streak. Suppose if a mineral is colorless or crystal color in its inherent form, it may shows its stakes may be white. A very common example, you are known about the rock salt. Okay, sometimes in general, the rock salt are found in our market in solid form. Okay, in solid forms, this is actually a crystal watercolor or crystal type, mostly colorless. Sometimes, if it has some impurities, it shows some dark shade, but in general, it's colorless. And if you ground it for cooking purpose or use, so after grinding you may find it become white color like powdered sugar or like normal salt. Its color become changed. The another example is the all of you are nowadays known to Himalayan pink salt. These are actually rock minerals, another minerals. These are actually extracted from Pakistan, and then in Himalayan belt, extracted from Pakistan, and then it's transported or exported to India. Then India prepared it, processed with this salt minerals. These are actually large boulders, and then they shape it to different households, mm, uh, household things, something like plate or bowl or glass like this, some showpiece, or in some case for utilities. And another portion is grounded for cooking purpose or another use in medicine. So those portion is grounded. So in general, the Himalayan pink salt, these are the deep reddish color, color. And when it is grounded for in fine powder, it colors change and it become pink type color. That means the color become fade. So these are the difference between color and stakes. And many minerals, these are there is some change in the color and stakes. So and the last one is the luster. Luster is the appearance of the mineral in the ordinary light. That means light reflection from the surface. That in general it's for the minerals, it may be looking like metal. Its luster is metallic, for example, or it may be looking like glass. Okay, sometimes minerals looking like glass. Suppose for diamond, this outer surface is looking like glass. So you may, so this is glossy. Or if it looks like metal, so you may suppose you may identify it as metallic or anything. So these are the luster, but many minerals may not reflect the lights, so they have no luster in some cases. So these are the properties, some properties of basic physical properties. So based on these physical properties, the primitive way to identify minerals. But with the technological advances, there are some advanced technique for mineral identification, like SEM and XRD. These are the actually laboratory experiment to identify the minerals. That means these are the advanced tools, some machines like SEM means scanning electron microscope. That means it's a microscopic imaging device or equipments. Those identify the its micro image or scanning image with the crystalline structure, its surface morphology, microstructural composition of minerals, density, etc. And sometimes it's compressed with EDX. EDX is electron. It's sometimes integrated with SEM. EDX actually shows the element. Okay, EDX actually shown its elemental composition. That means these minerals compressed which types of elements, maybe sodium, aluminum, or oxygen. So based on if you, once you will get you get the composition or the presence of specific elements, it is very easy to identify the minerals exactly based on the physical properties. Sometimes it may be difficult to find the exact minerals name because due to some impurities or some other conditions, this may be not show the real or ideal color or ideal luster, stakes, hardness, etc. That may be changed. So these are the advanced technique to identify properly. Here is some few example as we discussed earlier. Say feldspar, these have some steak noodles type, okay, some stick type, rectangular sticks, those are compressed together. And the mica, these are the one plane, that means some plate type, small plate type structure, microstructure, that means small plate types elements are compressed. The third one is the halite, as we discussed. Halite have the cubic shape, that means small cube, like the small sugar cube, compressed in a dense forms. Those are the halite. And the last one, this is the calcite. So this is also cube. You may find here these are also cube, but not in rectangular shape. That means the cubes are in the tapered shape. So all of these are not rectangular. So these are the actually a few images of SEM, scanning electron microscopic image of these minerals. So in theory, we just explain, but when we go for the advanced mineral identification, these are the actually out of our scope. Those are mostly used by the geologist, or those who are searching for the mining, related with the mining, geology, geologist, etc. So in those cases, they go for the advanced identification techniques to find it exactly. Then another one, the XRD. This is the best method for the mineral identification. Those are actually the X-ray diffraction. In these cases, some small grains of minerals are placed in the machine, and then X-ray beam is focused. Okay, X-ray beam is focused, and the beam is at a heat on the minerals. Then one portion of ray from the physics unit, one portion is reflected, another one is refracted or bounced. So the bounced portion is recorded, and with some procedure, this exact pattern, that means exact composition, the series of peaks are recorded in the this process, and those peaks, and then with some mathematical calculations and atomic spacing, etc., mineral crystal structure, all the details are known from this XRD test. Suppose in many minerals, in nature, it may have 2 or 3 form. Okay, suppose for iron, the minerals of iron may have many forms in nature. So for different forms, it's very easy. If you go for the XRD test, we will find the exact, we can find the exact minerals composition, including its crystal structure, composition, facing, body face or south face, etc. Each and every details are found in the XRD test. So these are the now advanced techniques recently used by geologists and mineralogists. Those are expert in this field. The recorded data is already recorded. So if you find a mineral in the field, you just simply collect this and go to the laboratory, then find which types of mineral it is. This is an example of XRD test, typical. And this is another example. So these peaks are actually represent the mineral. So these are actually just for showing the techniques. Those are not actually for study or memorizing. So these are the basics of minerals. Actually, in this lecture, today's lecture, I show some basic properties and some name of some basic minerals. But for exam purpose or for this course, you need to study some more minerals. So in next class, I will provide an assignment, okay, including the name of some minerals, rock forming minerals. So, and I will give the details guideline. So which types of property you need to make an assignment. You need to submit an assignment for showing all these the properties of those minerals. That means this will be later help for your exam also. So I will list of probably I will give you in the next class next week. I will list up some name of some minerals. Then you will search this in Google, or you may get help from books to list up its physical properties. It may be in tabular form or in paragraph forms with some figure, etc. So with all of this, you will make an note type assignment for based on the minerals. So our next term is the rock. Rock is the consolidated or poorly consolidated aggregates of one or more minerals or organic matters. It's not necessary always the rock is always formed by minerals. Sometimes it may formed by organic matters like peat or coal. All of you are known to coal. Okay, coal mining, it's a very common, and this coal is used in power generation on any or many other engineering sectors, steam boilers, etc. So coal or peat, these are the not the mineral rock forming minerals, or the rocks made from minerals. These are the actually results of organic matters sometimes. Or in lecture 1 I showed an example. So actually those are not fully consolidated aggregates. That means some organic soil or clay soil, those are consolidated, apparently looking like rock, but those are not fully rock. So the basic three types of rocks, these are actually igneous rock, sedimentary rock, and metamorphic rock. Okay, so three types of rock: igneous, metamorphic, and sedimentary. So, and we will discuss a cycle. Those are actually known as the rock cycle. So we will discuss, hopefully I will discuss this, describe the rock cycle in next class. Just today I am trying to show the rock. Igneous rocks. The igneous rocks are formed when the molten rock in the deep earth. Actually, I may skip. Okay, let's show on the last lecture. Right. Lecture 1. I skip some portion in the lecture 1 actually. Those explain our earth system. This is also important for this lecture. This is actually represent our earth system. So our earth system comprised of many layers. That means this is known lithosphere, hydrosphere, atmosphere, biosphere, etc. So in these portions, that means biosphere, this is common. Okay, and that's the next one, the earth system. The internal and external energy, that means the outer crust is cool, cold, and normally in a normal condition. But if you go for the core of the earth, if I show, this is the, okay, there is nothing. If I go for the core of the earth, that means going for further deep and moving towards the center of the earth, the temperature is increasing continuously. So in this case, if you go for the deeper, that means there you will find some molten lava type materials, and sometimes these are burst through the volcanic eruptions. So this is igneous rock. The igneous rock is the resulting form of it's taking problem. So the igneous rock, this rock actually the solidified form of the molten magma or molten lava. Those are comes from the deep earth, and when it's cold and solidifies, it forms the igneous rocks. Sometimes magma cools inside the earth, or sometimes it may come out by volcanic eruptions and then may cool down. Though when the lava is cools very quickly, so there is no crystal, the crystallization is occurs. And if it's cooled slowly, it's that crystallization will occurs. And sometimes maybe a gas bubble, actually there may have some gaseous materials in the deep strata of earth. So the some gas bubble are trapped into the rock, molten lava, and during the cooling process it create some void, so space, teeny holes in the rock. So these are the some varieties of the igneous rocks. So during its formation process, different conditions may arise. So based on these conditions, different types of igneous rocks will form. So later we will discuss the types of igneous rock. Another one, the sedimentary rock. These are the result of the eroded fragments of other rocks, or even from the remaining plant, animal, etc. Those are sedimented, and after these sediments, due to some geological process, and under pressure or compressed load, it solidifies. These are the called the sedimentary rock. One example is the sandstone. That means another one is the mudstone. Okay, and another one is seashells. Those are the formed from limestones. Actually, if the sand is go for the huge pressure, suppose sand are in the loose, all of you know sand is loose. So if you compressed it in a mold in a huge pressures one time for many years, including the heat and pressure, it may cause solid, it may cause some stone like materials solid. These are the called sandstones. Suppose similarly, if you compressed mud or clay in the pressure and at certain pressure, so it will create the mud stones, and similarly like limestone, etc. Sometimes fossils are also found in the sedimentary rock layer. So these are the some examples. And last one is the metamorphic rocks. The metamorphic rocks are the transformed form of sedimentary and igneous rock that have been transformed by the pressure, heat, and intrusion of fluid. That means due to the pressure, heat, and fluid intrusions, the metamorphic rocks are prepared. The heat maybe comes from the nearby magma or hot water spring, etc., or many other cases. Due to some tectonic causes, the metamorphic rock is formed in the earth. So this is the some three basic types of rocks and their explanation. And okay, next class we will discuss this physical properties,
স্যার
rock
একটা
cycle.
প্রশ্ন ছিল স্যার।
Okay, বলো।
স্যার আগ্নেয়াস রক এটা কি স্যার আমাদের ইঞ্জিনিয়ারিং এর কাজে ব্যবহৃত হয়?
ইগনিয়াস রক না, ইগনিয়াস রক ওইভাবে আমাদের কাজে ব্যবহৃত হয় না, কিন্তু তুমি আন্ডারলাইং লেয়ারে ইগনিয়াস রক পাওয়া যাবে। হ্যাঁ, ইগনিয়াস রক, মেটামরফিক রক, সেডিমেন্টারি রক, এগুলো আসলে আন্ডারলাইং লেয়ারে পাওয়া যায়। যখন তুমি এক্সপ্লোরেশন হবে, সাবসয়েল এক্সপ্লোরেশন আর সাবসয়েল ইনভেস্টিগেশন, সেক্ষেত্রে তুমি পাইতে পারো। বা অনেক ক্ষেত্রে ইগনিয়াস রক সেটা এক্সপোজড হয়ে যায়, হ্যাঁ, ডিউ টু জিওলজিক্যাল প্রসেস দেখা যাবে সেটা মাটির নিচে ছিল, বা সাবসয়েলে ছিল, হয়তো 100 বছর পরে সেটা এক্সপ্লোর হয়ে, ডিউ টু সাম ম্যাসিভ চেঞ্জ, এটা এক্সপ্লোর হয়ে উপরে চলে আসতে পারে, তখন তোমার ইয়ে হইতে পারে, এরকম আর কি।
স্যার তাহলে কি স্যার ওই জায়গাটা কি স্যার ইঞ্জিনিয়ারিং কাজের জন্য কি স্যার ঝুঁকিপূর্ণ?
না ওরকম কিছু না, এটা তো ডিপেন্ড করবে তুমি কি ধরনের কাজ করতেছো বা কিরকম, বাট আন্ডারলাইং লেয়ারের রক নর্মালি এগুলা গ্রেটার ডেপথে থাকে। আমি দেখাবো ইগনিয়াস রকটা অলওয়েজ এরকম ওপেন খুব কম পাওয়া যায়, যেখানে হচ্ছে তোমার কিছু রকি এরিয়া আছে, কিছু কান্ট্রিতে আছে যেমন কানাডা বা ইউএস এর কিছু পোর্শনে আছে, যেখানে হচ্ছে তোমার ভলকানিক ইরাপশন হয়, সেগুলো এলাকাতে দেখবা যে একটা রকি লেয়ার, মানে আপার লেয়ারটা, আর্থের আপার লেয়ারটা রক, বিশেষ করে কানাডা নিউ ফাউন্ডল্যান্ড এর ওই দিকটাতে পুরো রকি এরিয়া। ঠিক আছে, আম, তুমি দেখা যাবে যে মোস্ট অফ দ্য কিছু পাওয়া হিলি এরিয়া আছে, ওগুলো পুরোটা রক। ওগুলো অ্যাকচুয়ালি হয়তো মিলিয়ন ইয়ার্স এগো সেখানে তোমার এই ভলকানিক ইরাপশন হয়েছে, তারপরে পুরো এরিয়াটা রক হয়ে গেছে, এরকম আর কি। সো এটা সাম জিওলজিক্যাল ডাইভার্সিটি, এটা পাওয়া যায়, বাট এটা ইঞ্জিনিয়ারিং কাজের ক্ষেত্রে এটা ডিপেন্ড করবে তুমি কি ধরনের কাজ করতেছো, তার উপরে ডিপেন্ড করবে। সব ক্ষেত্রে ঝুঁকিপূর্ণ বা ওরকম ডিটেলস ছাড়া ইনভেস্টিগেশন বা তোমার পারপাসের সাথে কম্পেয়ার করে সেটাকে ম্যাচ করে তারপরে বলতে হবে যে কোনটা বেটার বা কোনটা প্রবলেম হবে। ঠিক আছে, আমরা জাস্ট এখানে এই করছে যেটা হবে এই এই মানে ডিটেলস গুলো একটু জাস্ট হিন্টস দিব যে কোন রক কিরকম হয়, রক সাইকেল, রক ফরমেশন, এদের প্রপার্টি কিরকম, এইগুলাই। তো এই পর্যন্ত আজকের ক্লাসটা আমি রাখছি। কালকের ক্লাসে রক সাইকেল, রক ফরমেশন এর বাকিগুলা ডিসকাস করব, প্লাস তোমাদের হচ্ছে অ্যাসাইনমেন্ট আমি দিব। অ্যাসাইনমেন্ট মিন্স মিনারেলস এর ডিটেলসটা আমি বেসিক গুলো পড়াইলাম, কয়েকটা মিনারেলস, এরকম আরো অনেক মিনারেলস আছে। মোস্ট কমন যে মিনারেলস, এরকম ইম্পর্টেন্ট কিছু মিনারেলস এর নেম আমি লিস্ট আপ করে দিব। করে দিলে তোমরা ওইটা পড়ে নিবা, প্লাস হচ্ছে একটা রিটেন অ্যাসাইনমেন্ট আমাকে জমা দিবা। তো ঠিক আছে, আমার সাথে আবার নেক্সট ক্লাস হবে তোমাদের এই কবে হবে, নেক্সট হচ্ছে বুধবারে। ওকে, তাহলে আমি আর কারো কোনো কোশ্চেন থাকলে ক্লাসরুমে করতে পারো, আমি লেকচারটা আপলোড করে দিব, পিডিএফ করে এটা দিয়ে দিব, ভিডিও লেকচার তো দিবই। সো মোটামুটি এই পর্যন্ত আমাদের দুইটা আজকের ইন্ট্রোডাক্টরি ক্লাস প্লাস রক মিনারেলস এর কিছু ডিসকাশন। হোপফুলি ক্লাস শেষ, আমি ক্লোজ করে দিচ্ছি।